Hello everyone, I am Yalini Jaishankar from Department of Physics, Bharathidasan University. In this video, we are going to discuss about material processing with laser using drilling method. We are going to briefly discuss about drilling process, classification of drilling process, and then advantage and disadvantage of drilling process. Before discussing about the drilling technique, we first focus on the character of laser. The main character of laser are monochromaticity, directionality, coherence, and highly intense. Why we move to laser technique? What are all the main drawbacks in a conventional method of drilling? Now we are going to discuss about the drawback in conventional method. In conventional method, it is difficult to drill in hard and brittle material. In that material, making hole with a small diameter are impossible. Usually, problems such as breakage of tool bits, wear, tear, etc. are encountered in conventional drilling process. To overcome this problem, laser technique is used. So that now we move to laser technique. Laser is an excellent tool for making hole in hard and brittle material. Using laser technique, we can make hole in very small diameter without any damage. With laser, it is easy to drill hole with a diameter as small as 10 micrometer through the hardest of material. For efficient and precise drilling process, laser technique is used. This is a simple diagram of drilling process using laser. First, a laser beam is incident on a workpiece. When a high intense laser beam incident on workpiece, it make a cavity on a workpiece. While making a cavity, the material get molten and then a plum of vapor come out from that cavity. Now we are going to briefly discuss about a drilling process. To have a high aspect ratio, that means the ratio between hole depth and hole diameter, that is our aspect ratio. This is a controlling tool for a drilling process. To have the high aspect ratio, we use high power laser to drill to large depth. While drilling, a pump of vaporized matter forms and this pump blocks the laser beam from getting in contact with the material. This pump is formed at the surface of the material. So, energy contained in the laser pulse is absorbed by the pump and not by the workpiece. If several pulses from a laser source are sent to the same spot of the workpiece, the depth of the hole can be increased. So, highly focused laser are used to make a drill on a workpiece. These are all the overview of drilling process. With the help of this process, we are going to classify a drilling process. There are 4 classifications: single pulse drilling, percussion drilling, trepanning drilling, and then helical drilling. In that 4 classification, first 2 are unmoved laser beam, and the last 2, that is trepanning drilling and helical drilling, are moved laser beam technique. This graph represents a precision versus drilling duration. First, single pulse drilling. In that single pulse drilling, precision is low, but the time duration to drill a workpiece is also low. And then percussion drilling. In that, precision is slightly increased comparing to single pulse drilling, and then duration also get increased. These 2 techniques are based on unmoved laser beam. That means the laser beam incident on a workpiece is fixed. Next, trepanning drilling. Trepanning drilling, precision is get increased and then duration also get increased. And then helical drilling, it is a highly precise technique, and then it also take a long duration comparing to these 3 classifications. Now we are going to briefly discuss about that 4 classification. First classification is single pulse drilling. In that single pulse drilling, there are 5 steps are commonly used. That steps are melting and vaporization occur at the bottom of the hole. When we insert a laser beam, that get melts and the vaporization occurs at the bottom of that cavity. As we use single pulse drilling, the hole get widening. Then solidification of melt at the hole wall. Shadowing of laser radiation and closing the hole. That is, the plumb will close the cavity hole so that the laser beam will not enter into the cavity, that is a hole. Then recondensation occur on the surface of the hole and then a laser beam is allowed into that hole. This diagram clearly explains these 5 steps. Next, the geometrical structure of the hole made by a single pulse drilling. The diameter of the hole, that is a drilled hole, is 0.05 to 1 millimeter. Aspect ratio is less than 20:1. Then the duration is less than 1 second. What the aspect ratio actually signifies? It is a ratio between hole depth and hole diameter. The next classification is percussion drilling. In the drilling, it is similar to the single pulsed drilling, but the main difference is here more than one laser beam is used. It will take long duration comparing to single pulsed drilling. In the 4 classification, percussion drilling has a highest aspect ratio. In both single pulse and percussion drilling, laser beam is fixed. In both single pulse and percussion drilling, laser beam is fixed. The geometry of the hole is diameter, it should be 0.05 to 1.5 millimeter, and then aspect ratio is less than 50:1. The drilling duration is 1 to 5 seconds. Next classification is trepanning drilling. In this drilling, laser beam is moved. Comparing to about 2 methods, that is single pulsed drilling and percussion drilling, this method is more precise and will take more time. Using trepanning drilling, we can get various geometry such as cylindrical, conical and what shape we want. Geometry of hole drilling, diameter should be 0.5 to 10 millimeter, and then aspect ratio is greater than 40:1. Then duration, it will take 5 to 20 seconds. A small clip of trepanning drilling. Here we can see that by moving the laser in a circular shape, we can obtain a circular hole. Helical drilling, it's a last classification. Rotation with respect to workpiece requires a circular beam profile. Formation of melt is very low, so that the melt will not resolidify in the wall of the drill. So we observe a smooth drill wall. The geometry of the drill are diameter 0.03 to 1 millimeter and the aspect ratio is 40:1. Duration, it will take more than 1 minute. A small clip of helical drilling is Then we move on to the advantages of a drilling process. Material like gemstones, ceramics are hard and brittle in nature. It is extremely difficult to drill in this material by any conventional method. Laser is an excellent tool for such operation. It is easy to drill hole having a large hole depth to hole diameter. Hole is very fine dimension of less than 0.001 centimeter can be made on nozzle and metallic plates. Usually problems such as breakage of tool bits, wear, tear, etc. are encountered in conventional drilling. To overcome this problem, we can make use of laser drilling. Precision and close pattern hole can be produced without the heat spreading into the adjoint areas. There is no physical contact between tool and material, and hence there is no contamination will occur. And some drawbacks, that is disadvantage of drilling process are: hole with large aspect ratio, considerable tapers may be present. What the taper actually means? That is a uniformity in hole diameter, that is taper. Here the hole diameter get decreased when we move downward. Thermal effect. Due to heating, a haze may be present around the hole. Laser installation need high capital investment. So these are all the main disadvantages in using drilling process. Thank you for watching.